Good afternoon. The last part under theory of second module is strain rosette. After this particular topic, we will be solving problems on strain. So this marks, after the problems are done, it will mark the end of module 2. So what is the strain rosette? Let us look at it. The principal strain and their directions, shear strains, etc. at any desired point in a given strained body can be obtained by measurements of the normal strain by 3 strain gauges in the directions in which they are oriented. Alright, so we are going to take up 3 strain gauges. We are going to orient them along the direction of principal strain and the direction shear strain at any given point in the strained body. So this arrangement of the strain gauges is called as strain rosette, and the strain rosette consists of a group of strain gauges of equal gauge lengths. We have two different types of strain rosette. The first one is rectangular strain rosette or equiangular. The second one is equilateral or delta rosette. So let us look at the first one, that is rectangular or equiangular strain rosette. Alright, so it will be represented as, this is your strain gauge. So this is another strain gauge. So there has to be 3, always 3, no less or no more. It is called as equiangular, so 45 degrees each. Alright, so this is gauge 1, gauge 2, gauge 3. It is nothing but, it can be represented as A, B, C. 3 strain gauges. The total angle is 90 degrees, right? So individual angle is going to be 45 degrees. This is 45, this is 45. Okay, so we have theta is equal to 0 degree, theta is equal to 45 degree, theta is equal to 90 degree. Yes, so normal strain, let us find out the value of normal strain, that is epsilon A is equal to epsilon x when theta is 0 degree. Alright, then epsilon B is equal to epsilon x plus epsilon y by 2 plus gamma xy by 2, or I can write it as epsilon A plus epsilon c by 2 plus gamma xy by 2. Theta is equal to 45 degree, and epsilon c is epsilon y, that is theta is equal to 90 degrees. All these 3 are derived from the previous video where we had written epsilon theta as epsilon x plus epsilon y by 2 plus epsilon x minus epsilon y by 2 cos 2 theta plus gamma xy by 2 sin 2 theta. Yes, in the previous video we had written this. We had arrived at the strain component at a point in any direction. We had obtained the value of epsilon theta as well as gamma theta. So based on this relation, just substitute theta is equal to 0 degree, you will get the first equation. Theta is equal to 45 degree, you will get this equation. Then theta is equal to 90 degree, you will get this. For theta is equal to 0, it is epsilon A, that is the normal strain of gauge 1. If theta is equal to 45 degree is epsilon B, that is the value of strain along second gauge. Theta is equal to 90 degree is epsilon C, that is for the third strain gauge. Alright, now coming back to the principal strain principal strain. The formula is epsilon 1 2, we had written that one. So epsilon 1 comma 2 is epsilon x plus epsilon y by 2 plus or minus half of under root epsilon x minus epsilon y by 2 plus gamma square xy. We had written this formula under principal strain. Yes, so just substitute in the place of epsilon x as epsilon a, in the place of epsilon y as epsilon c. Alright, so this gets rearranged as epsilon 1 comma 2 is epsilon a plus epsilon c by 2. The reason it is epsilon y is c is x and y. So this is x, this is y. So epsilon a, epsilon c. Alright. So epsilon a plus epsilon c by 2 plus or minus half into under root of epsilon a minus epsilon c by 2. Thus 2 times epsilon b minus epsilon a minus epsilon c the whole square. So gamma xy is 2 times epsilon b minus epsilon a minus epsilon c. Now let us find the direction of principal strain with respect to x-axis. The formula is tan 2 theta is equal to gamma xy minus epsilon x minus epsilon y. So just replace tan 2 theta is gamma xy is 2 times epsilon b minus epsilon a minus epsilon c divided by epsilon a minus epsilon c. Alright, we can also find the values of maximum shear strain. So it is gamma max, which is equal to under root epsilon x minus epsilon y the whole square plus gamma square xy. Then principal stresses also can be found. They are going to extend the question and ask you to find maximum shear strain, principal stresses with respect to just giving the strain values. So stress and strain are related like this. Sigma max is equal to E divided by 1 minus mu square epsilon 1 plus mu times epsilon 2. Then E minimum is equal to E divided by 1 minus mu square epsilon 2 plus mu times epsilon 1. Then we have found out maximum shear strain. We can also find maximum shear stress. That is tau max, which is E times gamma xy by 2 times 1 plus mu. Alright. Now for the second arrangement, that is equilateral. That first one was equiangular or rectangle. Second one is equilateral or delta rosette. Okay, as the term goes, equilateral, so obviously it has to be 60 degrees each, the angle between them. This is gauge 1. We have gauge 2, and then we have gauge 3. This is gauge 2, this is gauge 3. The angle between them is 60 degrees each. I can write it as A, B, C. So this is 60 degree. The entire angle is 120 degree. So in the same way, if we substitute theta is equal to 0 degree, you will get epsilon A is equal to epsilon x plus epsilon y divided by 2 plus epsilon x minus epsilon y by 2. Then theta is equal to 60 degree, epsilon b as epsilon x plus epsilon y divided by 2 plus epsilon x minus epsilon y divided by 2 into minus 1 by 2 plus gamma xy by 2 into root 3 by 2. Then theta is equal to 120 degree. So epsilon c as epsilon x plus epsilon y divided by 2 plus epsilon x minus epsilon y divided by 2 minus 1 by 2 plus gamma xy by 2 into minus root 3 by 2. Okay, or I can write epsilon x is epsilon a, gamma xy as 2 by root 3 times epsilon b minus epsilon c, or epsilon y can be written as 2 times epsilon b plus 2 times epsilon c minus epsilon a whole divided by 3. Alright, so we can write that principal directions, that is tan 2 theta is equal to root 3 times epsilon b minus epsilon c divided by 2 epsilon a minus epsilon b minus epsilon c, or principal string, that is epsilon 1 comma 2 is epsilon a plus epsilon b plus epsilon c whole divided by 3 plus or minus under root 2 by 3, under root epsilon a minus epsilon b the whole square plus epsilon b minus epsilon c the whole square plus epsilon c minus epsilon a the whole square. So we have found the value of principal strain for both the different types of strain rosettes. So this marks the end of module 2 with respect to theory. In the next class we will be solving the problems.